Good morning, friends. This is Durga again from IT University. Today we'll be talking about Uzi. We started with the setting up the development environment, and then we proceeded with Spark, and we have seen Hive, Scoop, etc. And now we will be uh, getting into another not so very important but useful tool called Uzi. The reason why I'm saying it is not very important because Woozy, whatever benefits Woozy bring are already covered as part of the yarn. Hence, instead of using Woozy as workflow, most of the companies start using more flexible workflow tools such as Azkaban, Airflow, etc. So let me give you the names. Azkaban, Airflow, etc. But still, we need to learn Uzi because it's part of the Hadoop ecosystem or big data ecosystem, and it comes as as the integral part with both Hortonworks as well as Cloudera distributions. Hence, having knowledge will help, but you need to have exposure to other workflow tools such as Azkaban, Airflow, which are open source workflow tools. Okay. So let me take you to the main course page. Again, I didn't update the content yet on the Big Data Engineer immersion page for Uzi. I have videos in my YouTube YouTube channel. I just have to take some time and start uploading the content over here. The reason is I am busy with the lab, and once the lab is done, I also want to revamp the website, and I will take care of adding the content as part of that effort. However, I will try to cover as much as I can as part of this. And then Uzi is a small tool. You just need to understand how to develop the workflows and how to invoke those workflows. That's the main idea behind Uzi. Okay. So for today's demonstration, I will be using CloudX Lab again. But in future, we will have ITversity Lab. I hope most of you might have got the notification from me. So I launched a website called bigdata-labs.com over the weekend. And right now it is in the preview mode. It's a 2-node cluster. I will walk through the cluster in a moment. And you can sign up for free for the for next couple of weeks until we extend. Even after extending to 8-node cluster also, I will give access to you guys at least for a month. For others, I will give only for a week or two. But for you guys, I will give at least a free access at least for a month, even more, depending upon how much traffic I'm getting. As of now, in the preview mode, you just have to click on this sign in or sign up button. You can use Google, Facebook, or LinkedIn, or even local authentication. So click on Google Plus and log in to your login with Google. And as of now, we will see the lab credentials directly. But once we open for paid subscriptions, if you are not paid subscriber, you will get the plans page. And using the plans page, you have to pay, make the payment. And then once the payment is done, you will get access to the lab. So bigdatalabs.com is just a website which will give you the information to access the lab. Here you have the user ID, password, and the console. And if you click on the console, on the left side, you will get the content from ITversity. On the right side, you will get the lab access. And you can actually resave this one. If you want to read, you can actually read it like this by going to the appropriate content. If you want to practice, you can increase the size of the lab. Okay. And then here you get the credentials for the lab. This will give the username and this will give the password. Let me try it again. It has to prompt for the username. Sometimes it is not prompting. We will try to fix that issue as soon as possible, but for now you have to just refresh. So copy the username, paste it, and then copy the password, paste it. So copying the password, it works with Chrome and Firefox. If you are using Internet Explorer, I am not sure, but Safari, it is not working. So try to use Chrome or Firefox if it is Mac. If it is Windows, please test in on the Internet Explorer. If it does not work, let me know. But it works on Firefox as well as Chrome. So now you are in the lab the same way as CloudX Lab. You can run Hadoop FS commands. You can run Hive queries, etc. Okay. And also in the same page where you get the lab credentials, you have the quick links. So if you have any issues, you can click on forums and start raising the issues. So I'm creating a unified platform, unified forums platform for all the issues, whether it is big data labs or even while learning. If you run into any issues or if you have any doubts, you can start raising those doubts and issues as part of the forums. And I'll be making a bunch of people moderators. If you are interested, let me know. I will make you moderator to this website. Okay, so you have to sign up in the forum. Let me open some other browser and let me sign out here. Okay, and if we click on login, it will take Google Plus as well as Facebook login. Let me see if people can watch. Yeah, they are able to watch the videos. Okay, so you have the Google Plus login as well as Facebook login. You can click on either of them. I am also planning to include LinkedIn also. And then once you log in, you will be able to raise the topics on any of the issues. And also, I am providing access to Ambari. So you can see the quick link here. Ambari, you will be configured. If you click on this, again, it will take you to the web console without the content. Okay, and this will give the access to resource manager. If you want to see what is happening on the cluster, you can go to the resource manager. It will give the access to job history server, Spark history server, and also I have opened up NameNode web interface also. But I haven't provided the link over here, but I will add that also very soon. So you can get all the details about the about accessing different links of the lab over here. Okay, and also there is a Learn tab. If you click on the Learn, you have the courses such as CCA 175, HDP, CD, Spark, Scala, Big Data Engineer, Immersion courses. If you click on the lab here, again, left side, you will get the CCA content directly. On the right side, you will get you will get the prompt to log into the lab, and you can read on the left on the course, and then on the right, you can actually practice. Also, you can go to Ambari. It's a quick preview. I already, if you go to the lab, if you go to the lab, I have provided a video about how to access everything. So you can go to this video. It's a 30-minute video, and try to understand how to access the lab effectively. I'm just giving a quick preview here. For detailed instructions, you can go through this video. Okay, now if we go to gw01.itversity.com and log in with the lab credentials, again, you have to copy paste the username and password from the lab credentials page in the bigdatalab.com, and you have to use the same username and password. And then you will get a read-only view to the cluster the same way as CloudX Lab. You can see the cluster configuration over here. As of now, we have 232 GB servers with 8 cores. Eventually, there will be 8 32 GB servers with 8 cores each. Okay, and then you can also access HDFS files and Hive web console here. If you click on files view, you will go to the file browser, and it starts with the root file system. For each of you, you will get a user space, and you can click on this, and you can see the files from web console files view in Ambari. And also you can go to Hive view, and you can actually run the Hive queries over here. You can choose the database, your database in which you want to create the tables. We will not be creating a Hive database for you. You can actually create a database directly in the worksheet. Create database command, database will be created, then refresh it, and the database will be shown here. Choose your database and start creating the tables. Okay, and on top of it, if you have to run Scoop, again, go to the video. I have a MySQL database, retail underscore DB in Scoop. I will create few more databases by the time we go to GA, or when we launch the paid subscriptions. By that time, we will have a dedicated MySQL database, and we will have multiple databases where you can actually uh, play around with them. And also, we will provide provide access to Postgres also. Not only MySQL, we will try to give access to Postgres also. So you can import and export data using Scoop from Postgres as well. Yes, we are using the same Hortonworks. Cloudera is not free, and there is no difference between Cloudera and Hortonworks. Both are same. Uh, Only the web interface to manage the clusters is different. If you are aiming for the developer, you should not be worried about it. You should be confident enough to work um, in either of the environment. That is correct. Only Cloudera manages difference. We will be providing access to Hue also. If you look into, if you go back to the Big Data Labs in the quick links, you will see the Hue also. Hue will work similar to this. Files view, Hive view, similar to this. You will get access to almost each and every component in Hadoop ecosystem. HBase, etc. Everything will be under one umbrella once Hue is configured. We are working on that, and for Hue also the username and password will be the same. Okay, let me go back to the Big Data Labs. So please use it and let us know the issue. You can hack, you can abuse, you can do whatever you want, and we would like to hear most of the issues. By the time we go to the paid subscriptions, we want to solve most of these issues and make it as friendly as possible to the paid subscribers. Okay, so let me go here. So Hue, it is not configured yet. Once it is configured, you can actually try Hive, Pig, Scoop, everything from Hue itself. Okay, so now let's go to the main agenda of today's session, which is Uzi. If you have any questions about the lab, you can ask anytime. And make sure you sign up to discourse, discuss.itversity.com, so that you guys can start asking questions, and we will try to respond as quickly as possible. Everything with respect to payments, user authentication to the lab, or user authentication to the Big Data Labs website, or even Spark, Hive, Pig, Scoop. Even we want to make it a uniform platform for all ITversity content, which will eventually cover cloud, DevOps, almost everything in IT. Okay, so yeah, let's go ahead with Uzi. So let me first do whiteboarding, and let me explain you the reasoning behind the necessity of workflow tools. Okay, so I'm launching essentials here. Yeah, they have explained as part of the introduction sessions early in the course. We will have different types of databases from which we need to get the different types of data sources from which we need to get the data. One is relational databases, RDBMS. Other one is weblogs. And third one is flat files. okay, flat files, which are typically delimited. And then we have the Hadoop cluster here. And eventually we want to visualize the data. If it is analytics kind of use case, you want to visualize the data. If it is means in the end, you have to visualize the data in by one means or the other. If it is analytics or batch reporting, you just connect your BI tool to the Hadoop cluster using Spark connector or Hive connector, or you have to port the data from Hadoop into a reporting database, and you can visualize the data. If you want to use it for the recommendation engines, then you have to use NoSQL database to give the recommended products when you try to search for the product. So to get to that level of getting data for the visualization, you have to do quite a bit of data extraction. So you have to get data from RDBMS to Hadoop. You have to get data from weblogs to Hadoop. You have to get data from flat files to Hadoop. And to get data from RDBMS to Hadoop, we use tools such as Scoop, or sometimes, and this is very important point which you need to understand. So Scoop, if someone gives, let's say, 16 parallel threads or 32 parallel threads, and if they start a Scoop job such as import all tables, then for each and every table there will be 32 parallel threads, means 32 parallel connections to the database, and then it has to fetch the data. So what it can do is it can bring down the source database. If there are too many threads reading too much of data, your database will become IO bound, and your database will start performing poorly for the transactions, which is the main purpose of your database. For example, if it is a Flipkart website or Amazon website, your RDBMS is primarily to store the information about the checkouts, orders, etc. And if someone else is reading a lot of data in huge batches, then the checkout process might take might start taking longer, which is not good. So at times, instead of using pull strategy, using Scoop is primarily used for pull strategy to extract the data from source database. So this is not related to Uzi, but this is a typical problem where people encounter when they try to use Scoop. As I'm discussing about getting data from different sources, I just want to highlight this issue. People might not use pull strategy, even if the data source is a relational database, even if Scoop is capable of pulling the data, because it can create contention in the source database. For that reason, we also use something called push strategy. When it comes to push strategy, it's the source application team responsibility to give the data to you in a accepted format. So you both have to sit together, the source team and the target team. In this case, probably Hadoop development team has to sit together and come up with technical specification, wherein you tell them how the source team should push the data. What is the file name structure? What is the delimiter they should use? And all those details you have to pass on to them, or they will tell that we will give the data in this format. You have to accept it, and you have to negotiate on the terms, and you have to come up with a common technical specification where they provide the data complying to the technical specification, and you write your data integration interface to read the data from those flat files and write into HDFS. Again, here, if it is push strategy, the strategy is to get data to flat files in an accepted format, and you have to have your data integration application to get data from those files and load into the target Hadoop cluster. So you need to have idea about both pull and push strategy, because you need to understand the caveats of using Scoop. If some developer use abnormally high number of parallel threads, it can hurt the business, and it can put the project in jeopardy. So make sure you understand this. Okay, so that's about Scoop. We typically we can use Scoop if we can pull the data from RDBMS and load into HDFS. And then for weblogs, we have seen technologies such as Flume, Kafka. We can pull the weblogs, read the data, and push into HDFS. And flat files, you can write wrapper program around Hadoop FS commands, or you can use Hive commands and write a wrapper around it, or you can have a complete Java application using file system APIs. It's up to you how you want to get data from flat files and load into Hadoop. Okay, typically people use shell scripts with Hadoop FS commands. So now typically to process the data, for example, if you have to do some recommendation engine, if you want to port the data for the recommendation engine, you have to get the data from RDBMS, you have to get the data from weblogs, you might have to get the data from flat files, and you have to join these data sets and do some aggregations, sorting, etc., whatever transformations you want to execute, and then port to the target database from which reporting will happen. So if you think about it, it's a multi-step process. So you have to get data from databases, weblogs, flat files, probably in parallel, sometimes in serial. Once you get data from all the sources, and if you have to join those, the data from all the sources, once you get data from all the sources, then only it should trigger the subsequent step to join. So first we extract the data from all the sources. Probably it can happen in parallel. Let's assume it happens in parallel. So so let me open another page here. I'm trying to draw workflow here. So you have a database, you have flat files, and you have weblogs. Okay, so this is database, this is weblogs, this is flat files, and then you get the data from all the three sources. And then if it fail, if getting data from any of the source fails, you have to I'm trying to draw the flow chart. I forgot the actual symbols. I think this is for the condition. If it is failed, if something is failed, then you have to raise an error and you have to discontinue. If it is not failed, the failure is no, that means it is successful. Then you have to run a subsequent job. Once you get all the data from all the three sources, you can do whatever aggregations you want, or typically we want to join the data first. So here we will join the data, and if required, we will aggregate the data, and then port the data to reporting layer. So this is a workflow. And these three things can happen in parallel. Once data is successfully captured from all the three sources, we have to wait until all the three data is captured from all the three sources. Once it is successfully done, then join the data. If you have to aggregate it. If you have to, then port the data to reporting layer. So this is called as workflow. And we need to have a sophisticated workflow tool so that we don't need to hand code. So there are several tools which can accomplish this. One is Oozie, which is native to Hadoop ecosystem, and which can invoke most of the Hadoop actions, such as Hive action, Scoop action, Pig action, etc. And easy to integrate with the Hadoop ecosystem, and you can set up the workflow, and the workflow will execute as a MapReduce job. Okay, but so I will explain a little bit later, but it is not very efficient as per the current trend. You should also have the knowledge about other workflow tools such as Azkaban and Airflow. and they are they can invoke anything, not just Hadoop component, even regular technologies also. And these Azkaban or Airflow can actually integrated. Okay, but the way they run is significantly different from Uzi, and they are good enough for most of the projects. And Uzi is a little bit more complicated compared to them. Anyway, I don't want to get into too many details with respect to Azkaban and Airflow, but I will give you a architectural differences between uh, Azkaban and Uzi. Once I cover the Uzi, we'll come back to that once towards the end of the session. It's Azkaban, Azkaban. I already typed earlier also. Okay, Azkaban Airflow is correct. Airflow, Airflow, and then Uzi. Okay, Uzi is native to Hadoop. Azkaban is LinkedIn's product. Airflow is Airbnb's product. Okay, anyway, now I am logging into CloudX Labs. Okay. Okay, so now we are in the CloudX lab. So Uzi comes with an examples. So it's better to start with the examples itself. Let me give you the path. Okay. So the path is user HDP, and you can search for star Uzi star examples. And it's a tar file, so don't give .jar extension, you will not be able to find. And this is the tar file which you can use to explore Uzi. Okay, so you can copy to your home directory in CloudX lab, or even once I open my lab, it's the same. It will behave in the similar fashion. Okay, so CP, copy this one to the home directory, and you can see the jar file here. I'm sorry. Okay. Okay, let me see what I have. Yeah, let me create a new directory, mkdir Uzi demo, and then cp or move Uzi examples to Uzi directory. Sorry, shoot. Uzi demo. I have to copy it to Uzi demo. Uzi examples to Uzi demo. Okay, now I am going to Uzi demo here, and we have this tar file. So you can run tar xzf Uzi examples.tar.gt, and it will create a directory for you with name examples. So if you go to examples here and go to ls-ltr and go to apps, you can see a directory for each and every action Uzi support. There is a hive to action, there is a hive action, there is a scoop action. You can invoke shell script, you can invoke pig script, you can invoke MapReduce, and you can also invoke Java main program. Okay, so you can invoke whatever you want. And here it will give standalone examples for each and every hive action. But to develop more sophisticated workflow, you need to have idea about the individual components, and also you need to understand some advanced features about how to wait until all the three parallel threads are done, and then how to join the data, or how to join after this after these parallel threads are done, and you need to understand how to develop the linear flow also. So this is called as parallel flow, and after that we are doing the linear flow. So you need to understand how you can actually write one workflow for everything. But before that, you need to understand how each moving part works, and then you can actually integrate all the moving parts using some advanced features of Uzi. Okay, so to understand the moving parts, you can go to any of these things. So let me take the example of Hive 2. Okay, for some reason Hive have issues and it does not work. You can actually use Hive 2 rather than Hive. Hive 2 connects to the Hive using Hive thrift server, whereas Hive connect using native Hive command line interface, and it has some issues on CloudX Lab. Okay, and you will run into issues in other environments also. It's a little bit tough to troubleshoot that issue and fix it. But if you use Hive 2, it uses the web client through thrift server, and it works without any issue. So I'm taking you to Hive 2 directory, and here if you see, go to any directory, you will find a job.properties and a workflow.xml and optional other files. By default, you will see the job.properties and workflow.xml for each and every action, especially if the action is related to Hadoop ecosystem, like pig, scoop, MapReduce, etc. Everything will have this job.properties and workflow.xml. So workflow.xml is the file which will actually define your workflow. So I'm opening the workflow.xml here. Okay, and here if you look at the convention, naming convention, this is the standard tag, standard workflow app tag, which you need to use, and you can give whatever name you want. In this case, the name of this workflow is Hive2WF, but for more sophisticated workflows, it should be uh, uh, based on your application name or application module name. Okay, and then the first tag after workflow tag is typically start tag. Okay, and as part of the start tag, we have to pass an argument called to, and we have to give some name here, and with that name there should be an action. If you see here on start, we are saying go to hive2 node, and then there is an action with name hive2 node. So we are starting with this action, and this action ends here, and all the logic means all the necessary parameters for this action are defined here. So first thing is you have to say what type of action it is, and the type of action is defined by the tag name. In this case, it's hive2. If you go to another sorry. Uh, if you go to another action or another example for another type of action, it is under Uzi underscore demo/examples, and then apps. This is the path, and let's go to MapReduce. If you go to MapReduce and if you open workflow.xml, okay, here you can see the tag name is the tag is MapReduce itself, whereas here it's hive2. Here it's MapReduce. If it is hive, you will see a hive. Okay, so this is the one which will tell what type of action we are trying to invoke. In this case, we are trying to invoke hive2. If this is the case, we are trying to invoke MapReduce. So for most of the actions, if it is related to MapReduce and Hadoop, and if it has to submit a job in the cluster, you need to pass your job tracker or resource manager IP address, which can be passed using a tag called job tracker. It takes both resource manager as well as job tracker. Whether you are using classic or YAR, it doesn't matter. It's the same tag which you use. I'll come back to that question in a moment. And then you also have to give the name node. And also, if you remember, when you run MapReduce jobs, if the directory already exists, it will complain saying directory already exists. So to avoid those kind of issues, we can have a prepare tag. So whatever you want to run before invoking the job, you can take care as part of the prepare. Typically, we delete and create directories in this prepare. And for delete also, there is a tag. For creating directories also, there is a tag. And then if you want to override any configuration parameters, at runtime, you have seen that we typically override parameters. So from Woozy workflows, if you want to override any parameters, and this is how you define all the properties using configuration tag, and you can specify as many properties as you want. And here you have to give that property name and the value which you want to override with. And then JDBC URL. For this is only specific to Hive 2. For Hive 2, we have to pass the JDBC URL, and this is the script which we are trying to invoke. And this script takes two parameters. One is input and one is output. And if you see here, we are actually parameterizing this some of the important information such as job tracker, name node. We are not hard coding, we are parameterizing those things. And also there is a parameter called wf call user. These are all parameters, and these parameters can be overwritten or can be defined using the job.properties. And while running the job, we will pass the job.properties, and whatever parameters that are defined as part of this will be can be used as part of the workflow.xml. So if I open job.properties here you can see name node is defined to localhost. So we have to modify this job.properties. And job tracker, and the IP address and port number is related to MRU1 classic. So we not only have to replace the IP address, we also have to change the port number, because we are using yarn here. We have to give the yarn resource manager port number, which I will show how to do. And then JDBC URL, we have to get correct JDBC URL for Hive 2 on as per our environment. And examples root. This is the directory name or parameter name which is used as part of the properties itself. You can see this examples root is used here. So this will be automatically replaced with this value. So as per this job.properties, the Woozy workflow application path is, you can copy paste this one. So these are all macros which will be replaced at runtime. And this is a system parameter which is understood by which can be understood by Woozy. And here the username is this one, training 8634. And then examples root is examples, which we got it from here. And then apps Hive 2. So this application, so Woozy WF application path is very important. Whatever application we want to run as Woozy job has to be deployed in the path specified under Woozy application path. So in this case, we have to copy the directory, Hive 2 directory, after fixing the work Woozy job.properties with appropriate name node and job tracker into this location, and then we have to invoke the Woozy job. I will get back to that in a moment after answering this question, and also after running few Woozy queries about validating the Woozy whether it is running or not, and then we will make the modifications, and then we will try to run the job. So the question is how to get the value for workflow XMLNS and Hive 2 XMLNS. So you can just use these examples. They are constant, and also you can go to the official Woozy documentation. So you go to Woozy user guide, go to the Woozy documentation, and Let me, you have to go to workflow functional specification. So Woozy have two things. It has both workflow as well as scheduler. Here I'm not covering scheduler because Woozy scheduler are not actively used. Either people use cron job if they want to do it in Linux native format, or if they try to use enterprise scheduling tools such as Control M, AppWorks, etc. No one uses Woozy scheduler. It's not it's as most of the enterprises have license for the enterprise scheduler, they go with it, or they go with cron scheduler directly instead of using Woozy as a scheduling tool. So I will be focusing only on the workflows. Okay, workflows are the ones which will actually do execute the logic in a controlled fashion. Okay, anyway, so here we are talking about Hive. So let's go to Hive action. No, I don't have the Hive action here. So let us see. It should have somewhere here. Hmm. Interesting. They didn't give the Hive documentation. Let me see. They should have. So workflow functional specification. So I will come back to that in a moment. For now, I will show you how to get that workflow details and all those things. So if you go to this documentation, or actually, yeah, here, workflow definition, uh, you will get it from here. So depending upon whatever you want to, it does not change, only the name will change. XML namespace for Woozy is the same thing. You just have to use the probably you might have to change the version of this. And let me see here what version we have. We have 0.5. You need to know which version is the latest one and which version you want to use, and you have to define that. Similarly, is the case with Hive. You have to go to official Woozy documentation to give the URI. But when it comes to distributions, you can take the examples itself as a starting point rather than starting with from scratch. Copy from the example. Most of the scenarios you don't need to worry about the XML namespace. It works as is. If you want, you can validate and make sure you have the right versions. That's it. Okay. So now let us understand how we can actually start validating whether Woozy is running or not, whether we can connect to Woozy or not, and then we will make the necessary modification, and also we will actually submit the Woozy jobs. Okay, coming back to here, you can go to the Woozy official documentation, go to running the examples. Okay, whatever I have covered, and it's the same thing covered over there. And then first you need to get the Woozy IP address and port number on which you are running, and uh, and then we can actually validate whether Woozy is actually running or not. So there is a command called Woozy admin. I'm checking if I have in my history. Yeah. So this is how you can actually check the status. So in our case, this is the IP address for our Woozy server, and this is the port number. The way you can go and get it is you have to go to Amari, which is running on a.cloudxlab.com. I have not configured Woozy yet on my preview lab, which I will be doing probably today or tomorrow. But we have most of the other components. But in CloudX Lab, they already have the Woozy. So you can go to Woozy, go to Woozy server, and this is the IP address. Okay, which is already copied. And if you want to get the port number, you can go to configs and let me see. Yeah, Uzi base URL. This is the one which you need to use. So you can copy this one. You don't need to search for the IP address separately. You can just uh, search for Uzi base URL, and this is the one which you need to use. And then you can say Uzi admin. Admin is primarily to get the version status, to start the Uzi server, etc. Uzi, you copy that link, and then status, it will tell you whether Uzi is running or not. It's in normal, so it seems to be running. And you can also get the version by saying -version. Okay. And then to submit the job also, this URL is important. This URL will be used for each and every command we run. Without this URL, you don't run any of the Uzi commands. Now let us understand how to modify uh, the job.properties, and then we will also see how to submit the job. So first we start with modifications to job.properties. In this case, we don't need to make any modifications to workflow.xml. I will explain how the complete flow as we proceed. So first we need to get the name node. So for that, what you have to do is either you use Ambari, or you go to etc Hadoop conf, go to coresite.xml, and this is the name node IP address. So copy this one. Make sure port number is also correct. Actually, better to copy this entire thing here. Okay, and then delete this and paste it. Now we told where our name node is. So when we submit the job, it can understand from where it can read the metadata to access the files. And then job tracker, you have to go to, first you need to understand whether you are using classic or yarn. If it is classic, you just have to go to mapledsite.xml and go for job tracker URL. We are using yarn, so we have to go to yarnsite.xml if you are doing from the backend. If you are using Ambari, you can go to the configs and get this information. And then here, you search for resource manager. And this is the IP address which you need to use. yarn.resourcemanager.address. Okay, so here we need to make sure that we have the right port number also. And then Hive to go to Hive here, or you can actually go to hivesite.xml also, and then search for JDBC. Go and this is different. This is Hive Metastore JDBC. You should not copy that one. It's not here. Let me delete this and go to settings. Somewhere it should show. Yeah, I think if you go to the summary and go to Hive server, somewhere it shows the JDBC URL here. Anyway, if it is not showing up also, you can actually get from the configs. Okay. So this is the one which you, the port should be Hive server 2 port, and the server name should be, you go to Hive, click on Hive server 2, whatever server name you get here, you can use this. Okay, so we can use this, and also you can go to hivesite.xml from the backend, etc hive view hivesite.xml. Okay, conf, and then view hivesite.xml, and then Hive server. They are using actually Zookeeper namespace. So let me see. Let me try this one. Probably it will work. Whatever you get here, it might work. If it does not work, then we will hard code. Because Hi server is running on multiple nodes for high availability, it's better to use the namespace rather than giving the physical IP address, and it will resolve automatically. So here we have to say Hive server 2, and uh, I'm not sure whether we should give port number or not. We will see. If it fails, then we will troubleshoot and we will try to fix. Okay, so we made all the changes now, and let me go to the workflow.xml again and what it is trying to do. Workflow.xml is trying to run a script.q script, and here it is expecting input data in this location. Okay, so let's understand to what it actually resolves. So it's a HDFS path from which it will read the input data. So it is using this one. So which means actually try to look for signing 8634, and our examples root is from job.properties, which is examples. So we need to have data in this location. Okay, so how can we get the data? If you remember from the beginning, we untar a file, tar file, and it has created a examples directory. So this is the file which is untarred, and it has created the examples directory. And if you go to this examples directory, here there is a source directory, there is the apps directory, and there is the input data directory, and that is the path which it is referring to, input hyphen data. And if you go to input hyphen data and ls hyphen ltr, you see table here. So this is the location which it is reading as input. So we need to have this in HDFS. So let me go back to examples directory again. Sorry, Uzi underscore demo. Okay, and let me see if I have examples directory in my HDFS, because earlier when I run for other batches, or when I try to validate, probably I might have already copied. So I'm seeing whether I have copied. In your case, it will not be there for sure. In my case, it might be there. It is already there. So I'm removing this directory. Okay. So when I copy, automatically everything will be, I would like to copy examples itself. So automatically apps will be copied, input data will be copied, and SRC will be copied. Those three are the directories which we have when we actually untarred. Okay. Now going back to workflow again. So workflow is under examples, apps, Hive2. This is the workflow which we are interested in at this time. If we go to workflow.xml, we understand from where it will read the data, and it will write the data to this path, and the directory is not there yet. Even if there is a directory, the prepare script will actually delete the directory and recreate the base directory for it. So if you see here, it is deleting the Hive2 directory, but when it is trying to create, if the base directory for Hive2 is not available, it will try to create the directory. Okay, so that's how it is trying to manage without erroring out using the prepare tag. And then we will also see what is there in that script.q, where it is, and what is there in that script.q. And again, I'm going to examples apps Hive2 and ls-ltr. We can see a script.q file here. So in the same directory, we have the script.q. And if you look into that script.q, what it is doing, it is just creating an external table stored as text file location, the input path. And from where we are getting the input path, in the workflow file, workflow.xml, we actually we are actually passing it as a parameter. So now again, if I go to workflow.xml, sorry, cat workflow.xml, you can see to the script we are also passing the parameters. One is input, so the input path will be used to create this external file, And also we are actually copying data from this table to a local directory using insert override directory command. So here we are not actually writing data to a table, we are writing to a HDFS directory, and even the output is nothing but a parameter which is passed as while executing the script. So parameters take the param tag, and you have to give the parameter name and the value you want to pass. So at runtime, this input parameter uh, uh, in the script will be replaced by uh, whatever input param passed while executing the workflow.xml. So I hope everything is clear till here. If everything is clear, then we will go ahead and try to submit the job after copying into HDFS. If there are any doubts, let me know. I will clarify those doubts before getting into the next step, which is to copy the files into HDFS and run the Woozy job. Meanwhile, I am going to the directory where we have the examples. Okay. So it seems there are no doubts. So let me copy the complete directory examples into HDFS. Ideally, we don't need to copy everything as long as the paths are available somewhere. As this is a self-contained package, I'm copying everything. But in true real world scenarios, true or real world scenarios, you don't actually copy the examples like this. You use the examples as a starting point, make the necessary modifications, and only have whatever it is required to your application as a bundle, and you have to copy only that directly to HDFS before running the Woozy job. Okay, so Hadoop fs -put examples. I'm trying to copy to my home directory, which is training 8634, and hit enter. It will create examples directory over there. Now we can actually do Hadoop fs -ls examples apps hive2. We should see all the files. Workflow.xml. This is workflow.xml. Forget about workflow.xml workflow.xml.security and job.properties.security. We are only interested in workflow.xml, job.properties, and script.q. So everything is copied. Let us validate. This is very important step, that our job.properties is reflecting our cluster configuration. So yes, it is reflecting our cluster configuration, and now we can run the Woozy job by saying Woozy job. I have an example here, -Woozy, and then the URL, Woozy base URL you have to use. Okay, and then you have to give the config path. And when you actually pass the config path, here we are in the Linux command line. Okay, so whatever path we give here, it has to be local path. You should not give the HDFS path. So we need to tell where our job.properties file is. That will act as our config. Okay, so in our local file system, the job.properties is under /home training 8634. I'm giving fully qualified path. You can give relative path also. Just to demonstrate that we have to give the local path, I am actually giving starting from the root path. I'm actually giving starting from root path. So here examples and apps hive2 job.properties, and then you have to say -run. Okay, then it will actually start the Hive job. So Woozy job -Woozy URL, then the configuration. So this is the, that's what I'm getting into, that I will demonstrate all those things. So GUI is asking how we can troubleshoot. So now it has given the job ID. Okay. So to get the status of the job ID, you can say Uzi job hyphen Uzi hyphen info and give the job ID. It is errored out, and you can see it has submitted a map reduce job and it errored out. So let's go to that job and troubleshoot where the issue is. Okay, I'm copying this one. We don't need to copy also. Let's go to the job history server here. Go to Ambari. Okay, something is okay. It's app timeline server. We are okay with that. So job history server URL will be under map reduce 2. Go to quick links, job history UI. And is this the one? Yeah, 1939. This is the one which is failed. So click on that. Click on map. Go to task. Go to logs. Most likely it could be Hive to JDBC URL issue, but let me see. Click here to get the full log. So let me change it. PI examples apps Hive to. I will try to come back to you on this about how to specify the JDBC URL in case you want to use the namespace. In this case, we will just hard code with the appropriate Hive server. So let's take the live Hive server. This is live, so we will use this one. Okay, and go back to here. Save it, and then we have to delete the job.properties in HDFS and copy it back. Or you can delete the entire directory and copy it back, but it will take some time. That's why I'm only copying one file. Okay, examples, apps, Hive to job.properties. I want to copy to /user training 8634. Examples, apps, Hive to. Now let me run. Now we got the job ID. Now let us validate. So now it is running. And even if Woozy is even sometimes if Woozy is succeeded here, still it might fail. So the reason, let me explain you. Once it is completed, I will explain. how it works. Let me go back here to the job history server. It errored out. So let me see. I need to figure out why it is erroring out. Okay, now let me see here. Map logs. Okay, there is already exists exception. Probably previously also it could be the same error. So let me actually see. I'm going back to the old job and checking the logs. Yeah, last time it's an unknown host exception. So this one is not correct. Okay. Now it's a different exception. It says already exists exception. So table is already existing. That's why it failed. Okay. So now let me drop the table. I'm going into Hive. It is taking very long time. Even some people reported this issue in my environment already. I think when a lot of people are using, it might slow down a little bit. Come on. Anyway, I will move on. It is taking very long time. This time it work, and let me explain how it work. So if it is successful, so there is one MapReduce job which will run the Woozy workflow, and then for each and every action, if it is a MapReduce based action, it will run another MapReduce job. Ideally, if it was successful, we should have seen two MapReduce jobs. One, this one which is Woozy launcher, and then another to run our Hive query. So as part of our Hive script, if you go here, and if we go to the script, as part of the Hive script, we are running insert command. Insert command runs a MapReduce job. So for this one, if it was successful, it would have created another MapReduce job. So one for running the Woozy workflow, and another for to actually run that insert MapReduce job related to that insert statement. And depending upon the complexity of the workflow, for running the Woozy workflow itself, there will be more than, in this case, it was only one job, but typically it can be more than one Woozy, one MapReduce job just to maintain the workflow. So the reason why workflow tools such as Azkaban and Airflow are successful is compared to Woozy is As I have mentioned to you earlier, depending upon the complex workflow, the number of MapReduce jobs that will be triggered can be pretty big. And also sometimes your Woozy workflow returns as successful, but one of the MapReduce jobs in the flow might fail. Okay, so it can cause some confusion. For that reason, instead of running Woozy, instead of running workflows using Woozy, which will use MapReduce extensively to control the workflow itself, we use centralized workflow tools such as Azkaban and Airflow. Azkaban and Airflow does not run the workflows in the form of MapReduce jobs. Instead, there will be centralized Azkaban server, which will be keeping track of your workflow execution, and troubleshooting the issues and running the jobs are much more straightforward compared to Woozy. That's why Azkaban is getting a lot of traction. The reason why Woozy was designed this way is, if you recollect the difference between MapReduce Classic and MapReduce Yarn, MapReduce with Yarn. With MapReduce Classic, we have one job tracker which takes care of resource management and also takes care of the job life cycle of the job. It takes care of both resource management and also job management. And at times job tracker gets bottleneck, and when we try to run complex workflows and from a centralized server, your gateway node or job tracker can become bottleneck. So to avoid that thing, Woozy is designed in such a way that it uses MapReduce, and as it runs in the form of MapReduce, it is a little bit decentralized and it was efficient when we run workflows with Classic. But with Yarn, it is already taken care with Yarn itself. The MapReduce jobs or job management is done by application master, and it can be distributed on any node in the cluster. Hence, whatever advantage Woozy brings onto the table is no more significant, and using Azkaban or Airflow are much simpler. And you should have knowledge about Azkaban as well on top of Woozy. Even though Woozy is losing some relevance, still you need to learn, because Woozy is native to Hadoop and it comes out of the box with Hortonworks or Cloudera, and you might have to you might have to understand the differences between tools like Azkaban and Woozy and decide which workflow tool you should use depending upon your environment. Okay, so you have to learn Woozy, and also better to have knowledge about Azkaban. They are very simple tools. As long as you understand their workflow tools and how to invoke the jobs and how to troubleshoot the jobs as a developer, that is more than enough. On my lab, I will try to set up Azkaban also. As of now, we don't have, but I will set up Woozy and Azkaban, and I will do a workshop, or I will record a video about that also. Okay. So Linux Bash script is sometimes your Hive query is might not be sophisticated enough to do everything. Okay, so there is a overlap. You can actually create a workflow in the Bash script itself. So in one of my projects, I just implemented everything as part of one Bash script. In that case, I have to get the data from Hive tables and export into Scoop. I have to join few tables and get the output and use Scoop to export. As I can invoke both Scoop and Hive from the command line, I just integrated both of the things through a shell script, and I just scheduled the shell script. So the workflow is part of my application itself. Whereas in more sophisticated examples, such as this, where I have to get data from multiple sources, and if I have to join after getting the data only on success, then for each moving part, you need to identify whether it has to be implemented using shell script or it has to be plain Hive command or Scoop command or pig script. or whatever it is, and then you have to implement that one, and then you have to integrate with the workflow tool. Okay, so a shell script so Woozy can invoke shell script also. So you can invoke shell script, you can invoke hive command, you can invoke pick command, you can invoke scoop command, etc. If you don't want to use Woozy, rather use a shell script to club several moving parts as a bundle, and if you want to take that route, it's up to you. It's all depending upon it all depends upon your design, how you want to do that. They provide the facility where you can invoke whatever you want, and you have to understand your requirements and come up with the effective solution to use different components and try to integrate them. And one more thing, Woozy might become less relevant is if you think about Spark. Spark versus MapReduce based application development. If you have to get the data from source database in MapReduce, you have to use Scoop, and then you have to use Hive queries. And Hive queries is just a query language; it does not have any scripting. If you have to do some pre-processing or post-processing, you have to write a wrapper on top of it. So here you are using different tools such as Scoop. Scoop have its own syntax and semantics. Hive have its own syntax and semantics, and then we have to write wrappers on top of it. And then to integrate all these things, we tend to use Woozy. Now with Spark, if you have to get the data from source database, you can use JDBC using Scala or Python. And then you can run Hive queries using the same programming language. Choose one programming language, Scala or Python, and you can actually reduce the number of moving parts. It's better to if it is Spark based application development, it's better to create an application using Scala or Python, reduce the number of moving parts, and integrate with the workflow tool. Workflow tool can be Woozy or an Azkaban. Okay, I hope I answered your question. If you have follow up, I will be glad to take it. So to answer your question, when do we go for Linux Bash script or Woozy? You can actually create a workflow with Bash script itself. Okay, but it all depends upon how you want to design, how you want to modularize your application, and have your moving parts separated. And depending upon how you want to integrate them, you have to use the workflow tool. It need not be Woozy, it can be Azkaban also. Okay, so so by now probably Hive might have launched. If it is the case, let me drop the table. Drop table, test, exit. Now let me run the Woozy job. Now it will be successful for sure. So go to MapReduce. Actually, quick links, resource manager UI. So it is still running. So this is the MapReduce job which is controlling the workflow. Okay, it is saying finished. We should have seen another MapReduce job. Probably we should see one more job. Means still it might have failed. Let me see. Yeah, still there is an error. So I need to go to the history here. Okay, let me go to the logs. It is still saying already exists. Okay. Yes. So let me finish this. I will come back to this. I will show you more sophisticated example, and uh, and sometimes even if there is not such functionality, you can integrate with your bash script. You can as part of the bash, you can get the logs, and you can integrate with sendmail or something. And also when you use enterprise scheduling tools, it itself will have the mailing capability. So if there is a failure, the enterprise scheduling tool such as AppWorks Control M will have those details. Means the capability of sending the email. It could be done with Uzi. Even if it is not possible with Uzi, your scheduling tool should be capable of doing it. You just have to develop an integration point between the two if it is required. So let me first uh, see why the table is not dropped. Here I need to go to the script. So cat examples apps hive to script.q. The table name is test only, so I dropped it. I dropped. Okay, I dropped in my database. That's why. Okay, I got it. I should not have changed the database. Or I can do this. I can actually create table in my database itself. Let me modify the script. PI examples apps hive to script.q. So here I will say training 8634 dot training 8634 dot. Okay, now we are trying to use my database. Put -p user training 8634. Yes, actually, it's F. Yeah. Now it is copied. Now I am running. Okay. So meanwhile, while it is running, let me show you a more sophisticated workflow where we can actually have multiple paths and then join them. So let me go to, I have the script in my local host on my Mac. So I'm going to that location, find name B, type D. Okay, so this is the location. Okay, so here I'm going to Uzi ETL. Okay, so this is a little bit more sophisticated example. Here I'm trying to club both MapReduce and pig, and I want to do it in parallel. Okay, cd mr-pig ls-ltr. Okay, and let's start with the job.properties. So job.properties, it's similar to whatever we have seen, and the IP address and port number of name node and job tracker. And examples root is this is the directory which I want to use. So in this case, in the examples, I just want to have this code. I don't want to have other stuff. Okay. And here, actually, it should have mr-pig rather than map-reduce. Here it should have it should be mr-pig. And then if you go to workflow.xml, okay. So here I am trying to integrate map-reduce with a pig script. You can do whatever you want. Okay, and first let us see what all actions we have. So the first action is map-reduce action. Let me copy this one, or let me cat. That will be better. So if you look into this, I have two actions. So we'll start with the actions. We have an action called mr-node. With name mr-node, and the action is map-reduce action. So this is the map-reduce job. This is how you actually submit the map-reduce job. I will I have a video already in my channel. You can go through it and you can understand how to submit a map-reduce job. Okay, and then there is another action called pig node, which have the pig action. So this is pig action. So this is a linear workflow. So linear workflow means executing one action after another action. So in this case, I'm trying to execute a map-reduce job. Then I'm trying to execute a pig script. So as usual, after the workflow tag, we will start with start tag. In the start tag, we will tell which node it should go to begin with. So in this case, the first action I want to execute is mr node. If I want to execute pig node, I can give the name of the pig action here, which is this one. Pig node is the action name, and then this is the action which will execute as part of that. So if I want to start with pig-node, I can do that here. I can give it directly here. So the order need not be same. You can define actions in the order you want, but the tags such as start, OK, error will actually control what needs to be done. Okay, in this case, the start tag is start action is mr node, which is nothing but a map reduce action. And towards the end of it, within that action tag, with for mr node, within that itself, after the map reduce tag, we have OK tag and error tag. As part of the OK tag, we are asking to go to pig node, which is another action. So this is a linear workflow. After executing the map reduce, if it is successful, it will go to pig action. If it is failure with an error, it will go to fail action. So for fail, we have an action called kill, or tag called kill, and in that we are printing a message here, and this message will be reflected in the logs. If you want to integrate with the send mail or something, on kill you can invoke a shell script which have send mail, and you can pass this message to that shell script, and you can integrate with it. There could be an action to send email directly also, which I'm not aware of. Most likely it might have. Okay, even if it does not have, as part of this kill on fail, you can actually integrate with the shell script, and you can actually invoke the shell script to send an email. Okay, otherwise you can go to the logs, and as part of the logs you will see this message. This message tag will only update the map reduce job logs, and you will see the error over there. And then if it is okay, if the map reduce job is successful, it goes to the pig node. And again, in the pig node also we have OK and error tags. If it is okay, we are saying to go to end, which is an empty tag. If you want to add additional functionality to notify someone, you can integrate that also here. Otherwise, you can just ignore. If it is error, in pig action also, we are going to the same tag, which is fail, same action, which is kill with name fail, and whatever message here, will be, means whatever functionality defined here will be executed. Okay, this is called as linear workflow. And then there is a parallel workflow under Woozy ETL. There is a parallel workflow. Let me see. Is this the one? Hive? No, let me see. Find workflow.xml, grep fork. This is not the one. I think this is the one, Woozy Hive. Okay, and here, this is also not the one. Okay. Okay, I made the mistakes. I have to search for xargs grep fork. Okay. So it's here. This is most important one. If you want to run several things in parallel and then you have to join if everything is done, then you have to use something called fork join. And this is an example. And you can actually get these things using Woozy user guide also. Okay, so in this case, let's start with workflow.xml. I have not updated any GitHub code or anything for now, but soon, once the lab is done, I will make this available as part of the Big Data Engineer course. If any one of you need this, just shoot me an email. I will try to attach on individual basis. Okay, so here, also let me do the cat. So again, it starts with workflow tag, and then first thing is start, and the start tag we are saying to go to forking. So as part of the forking, first let us review the actions what we have. We have 3 actions. One is Woozy states, and the second one is Woozy LCA details, and third one is Woozy join states LCA details. So there are 3 actions. One is Woozy states, one is Woozy LCA details, and third one is Woozy join states LCA details. In this case, I want to get data with respect to states as part of one action, and something called LCA details as part of another action. And this LCA details have a state code. Once I get data for both, I want to join LCA details with Woozy states. Once once both of the stuff is copied, and then I want to perform whatever I want as part of the this join action. Okay, so now we'll get to the beginning. Start, we are saying forking. So as part of the forking, we have to define what all actions that needs to be executed in parallel. So immediately when it goes to the forking, it will spawn multiple MapReduce jobs, multiple MapReduce jobs, one for each action from Woozy perspective. And depending upon the complexity of the logic, again there can be multiple MapReduce jobs as when the action is being executed. Okay, so you will see two MapReduce jobs for Woozy, and then depending upon the complexity of your program, you will see additional MapReduce jobs for each program. So here the action Woozy states and Woozy LCA details will execute in parallel. Woozy LCA details have millions of records, and Woozy states are only 50 records. So it will be done very quickly, whereas Woozy LCA details will take some time. But the way we can make the subsequent join action to wait is by directing both the actions on successful to common action. So in this case, we are saying if Woozy states is successful, go to Woozy join, and if Woozy LCA details is successful, go to Woozy join. And then we have a join action with name Woozy join. So this name and this name has to match. The name under OK2 for both the forked actions, and the join name has to match, which is Uzi join in this case. So once both are successful, then this action will be invoked. Okay, once both are done, then only this action will be invoked. If either of them fail, it will go to the fail tag directly. And then as part of the two, we are saying to go to another action where our join logic is available. Okay, and this is the script which will be invoked to join. So let me review those scripts also. That will make a little bit of sense for you. So we have Uzi LCA.q, Uzi join.q, and the script Uzi states.q. And if you go to workflow.xml, as part of the Uzi states, we are trying to run Uzi states.q. As part of the LCA, we are trying to run Uzi LCA.q. And for join, we are running Uzi join.q. And if you go to Uzi states.q, here we are just trying to create a table called Uzi states out of existing table. And then if we run Uzi underscore LCA.q, here we are actually creating another table out of existing table LCA details. LCA details is bigger table compared to Uzi states. So this job will take a little bit more time. But Uzi will wait until both the things are done to go to the join tag. And once it go to the join tag, it will invoke the join action defined for join, which is nothing but Uzi join.q. Here we are actually joining the tables which are created as part of the Uzi states and Uzi LCA details. This join will be only successful if both the prior jobs are successful. Otherwise, it will fail. Means it should not be invoked. That's why we are doing the forking and joining. It's called as fork join. It's very, very important. So in this case, if you have to design, you have to start. As part of the start tag, you have to go to the fork. In this case, there are three jobs or scripts, whatever it is. For each of them, we have to have a common join point. And then if all of them are successful, we can join. And as part of the join, we can do what we can invoke whatever action we want to and do the aggregation. And then you can do the linear workflows as many as you want until you port the data to the reporting database, which will support your visualization layer. That's how workflows can be designed. And the same principles can be applied even for Azkaban or Airflow, but the syntax, semantics, and the architecture are different. But the concept of workflow is same. So you need to understand the relevance of workflow and how you should be able to visualize how the workflow should be designed. And you can search for the features that are required. The terms will be different. In this case, they call it as fork to run in parallel, and to join, they call it as fork join. In Azkaban, the terms might be different. You just need to understand those differences. Then you will be able to design your application and develop or deploy your applications in the form of sophisticated workflows. That being said, that's it for Uzi. Again, I have given most of the important aspects of Uzi. It's up to you to practice and explore further. You have lab, probably with CloudX Lab, your access will be done by this week. After that, you can use my lab. I'll be providing lab for you for next 2-3 weeks, and probably there might be a week or so break when we actually implement the main lab, and I will give at least a month access to my new lab also, only for you guys. So you can practice over there for an additional month. And if you run into any issues at the time, even if it is not covered as part of the curriculum, if I am aware of it, I will try to help you. Okay. So that being said, we have covered most of the topics. Only thing I have skipped as part of the promised content is visualization using Tableau. I will try to get it as quickly as possible. I will run a small workshop for that, which will give the necessary knowledge around that. And then next 2 classes, we will be working on setting up Hadoop and Spark cluster. Make sure to join that class, those 2 classes. You will get a lot of good information, which is highly relevant when it comes to designing your applications and also designing your clusters. Especially most of you are 10 plus years of experience folks. So having that knowledge will definitely help in implementing the solutions effectively. That being said, if you have any questions, I will take a couple of them. Otherwise, we'll wrap up for today. Okay. Okay, then. Thank you very much. We make sure you join the next two classes. They're very, very important, and you will understand how the clusters are built. People who are on live also, please do join. I will be unfortunately for this session I could not create a invitation earlier. Sorry for the last minute invitation. I will try to create the invitation for next two classes as part of today itself. So please accept in meetup and try to join, and also start exploring my lab and start giving the feedback using discuss.itversity.com. That being said, thank you very much. Bye.